Hello ladies and gentlemen, I'm Carl Ross, of the University of Portsmouth, United Kingdom. Today is the 9th of March 2012. I'm going to give a lecture on how to use the commercial computer program ANSYS for analysing the vibration of a ring-stiffened cone. So first I pick on Preferences, I pick on Structural, I press OK, and then I pick on Preprocessor, I pick on Element Type, Add, Edit, Delete, and I add an element. For the shell of the cone, I'm going to use shell 8 node 93, and I apply that, and that is element type 1. And then for the beam, I'm going to use a tapered element. I'm going to use beam 44. I'm going to add that. I've got my two elements, and I close that, and then I'm going to pick on my real constants, pick on that, add, edit, delete, I pick add, and I'm going to put the shell, details of the shell first, so I'll click that, press OK, and I put in 1 millimeter for the thickness of the shell, and that will, if I apply to one node, it applies everywhere, and I press add again, and I get beam 44, press OK, I put in the cross, I'm going to put in a beam, cross section 5 millimeters by 5 millimeters, so cross section area is 25 square millimeters. The I Z is BD cubed and 12, which is 52, and the I Y is BD cubed and 12, which is 52, and the torsional constant for a square section is approximately BD cubed and 3, so I'm going to put 208 there, and that's fine. And then for the cross section area, for the other end, I'm putting in 25, and for the eye, 52, and for the other eye, you've got the IZ, the IY, 52, and then for the torsional constant, I'm putting 208, and I press OK, and that's fine, and I close this, and this is fine for ANSYS 11, but for ANSYS 13, you can't use the shell 93, you've got to use shell 281. Slightly different input, you have to press sections, shell, layer, add layer, and the identity is 1. And beam, you can use beam 188 if you want, but sections, beam, common sections, identity 2. And that's a slightly different input, the sectional properties. So now I'm picking on material properties, and this of course for ANSYS 13, you must put this in after you put in the material properties. I pick on material properties, I pick on material models, I pick on structural, I pick on linear, I pick on elastic, I pick on isotropic. Now be very careful with vibrations. If you draw it in millimeters, you draw your thing in millimeters, then the E has to be in millinewtons per millimeter squared. I'm putting in steel, so I'm putting 2E8 millinewtons per millimeter squared, and the Poisson's ratio is 0.3. Put that in, I OK that, and the density, I've got to put the density in kilograms per millimeter cube, and the density of steel is 7860 kilograms per meter cube, so I put E minus 9 to convert it to kilograms per millimeter cubed. I do that, and that's fine. I can close this now, I'll put exit, and that's fine. And I pick on, I'm going to model it, so I pick on modeling, I pick on create, and I'm going to create key points, and I'm going to create points in active coordinate system. And the first coordinate is at the top of the cone, which is number 1. The X location of that, which is at midpoint, at midline, is 0. The Y, which is the perpendicular distance of 1 from the base, which is 100 millimeters, and the Z is the radius, which is 25. So I apply that, and then I pick on the second key point, which is node 2. The X is 0. The Y from the base obviously is 0, and the radius is 50 millimeters. So I put that, and I've got my key points. Now that's fine. I've got to copy these key points. So I pick on. First I must do is to change the work plane. So I change the work plane to active CS to a specified coordinate system, and I'm going to choose 5. I've got X, Y, Z, theta X, theta Y, theta Z, theta Y is 5. I'm going to rotate it about Y, so that's 5. And then I pick on, I look for copy, I look for key points, and I pick the key points now. So I pick 1 there, and 2 there. I lift this up a little, I press apply, and I've got the number of copies I want is 3 copies. I have 3 key points across there, and I'm going to put the dy offset at 15 degrees, and the key point increment to be 2. That's fine. So I'm going to rotate that. So I press that there and do that, and I've got my points there. I must remember to change my work plane back to Cartesian system. So I do that, and now I'm going to create lines. So I look for create. Let's create. Let's create there. Let's create there. I pick on lines here. I pick on arcs. I'm going to put through 3 key points. I'm going to go left one first, right 1 second, middle 3rd, and I press apply. And then I do the next one, the left one first, the right 1 second, and the middle 1/3, and I press apply. I press OK. I do that. Now I'm going to create lines. I'm going to create lines. I'm going to create a straight line. And I'm going to pick on that point there and that point there to create a line. I'm trying to draw. I create that one, and I press apply, and then I create the next one. I create the straight line for the next one. I press that one there, number 5, and that one down there. I press that, and that's okay, and that's fine. I press that fine, that's okay, and I plot the lines. And that's fine. And now what I want to do is to create an area. So I pick on create areas, and I pick on arbitrary, and I pick it on by lines, and I'm going to pick the 4 lines there. 1, 2, 3, 4. I'm going to create an area there. I put that there, and I press apply, and I've created my area. It doesn't like that too much, but it's all right. There's nothing wrong with that. So I do that, and that's fine. And now I've got to mesh it. So what I do is I pick on meshing. So I'm going to look for meshing. There's meshing. I pick on mesh tool, mesh attributes, and I pick on I beg your pardon. I pick on mesh. Pick on meshing. Mesh tool. I pick on global set here, and that's shell 93. It's material number 1, real constant 1, etc. So that's fine. That's fine there. So I press OK. I then pick on line set. I pick on the top one there, and the bottom one there, and then I press apply. I make this number of divisions to 2 there, and I press apply, and then I press the left vertical and the right near vertical, and I press apply, and I'm going to split that up into 8 divisions. So I press that, and I've got 8, and that's fine. I've done that, and now I'm going to go to the mesh tool, the meshing tool itself, and I press mesh there, and I press this, pick that, I lift this up a bit, and I press OK, and I've got my mesh, and that's my mess, my shell. So I'm going to pause for a moment. I'm now going to resume my lecture. We've created the shell mesh. We've got to create the beam mesh. So I pick on preprocessor, I pick on meshing, there's meshing, there's meshing. I pick on mesh attributes, I pick on default attributes, I get shell 93, I don't want that. Mine is a beam, and the real constant is 2. So I pick on that, I press OK, and that's fine. And therefore, I have now got a model. So I pick on modeling, I pick on create, I pick on elements, elements there, auto numbered, through nodes, I pick on, so I'm going to put my beams now, and I pick on a beam here, that's the I and the J of the ends of the nodes, end of the elements, and the K represents a triangular plane about which the beam bends. I then pick on I, J, K, and remember I, J, K represents a triangular plane about which the beam bends. I pick on this one here, I, J, and K there, I press apply. I pick on this one here, I, J, and K there, and I press apply, and then I pick on this one here. I'm putting 3 ring beams, I, J, and K there. I press apply, I press I, J, and K there, and I press apply, I press OK, and then I plot my elements. That's fine, and that's fine. So what I've got to do now is to rotate the beam and the shell combination. So I'm going to change my work plane. So I change my work plane to change the active coordinate system to a specified coordinate system, and I'm going to put the coordinate system number 5 because that corresponds to theta 5. I'm going to rotate about Y. I press OK, and then I press, after I do that, I'm going to press copy. So I look for copy, I press copy, and then I press elements, and I put auto numbered, and I pick all there, and then I have a total number of copies is 12, because 12 30s, it's 360 degrees, and the node increment I put 100, which should be enough, and the Y offset I put in 30, fine, I press OK, and there is my model. And now what I've got to do is to change the work plane back to Cartesian, global Cartesian, because if I restrain it to anything like that I could be in trouble. And then I've also got to do the numbering controls. I've got to merge the items, so I merge the nodes because they're all loose, and then I compress the nodes because they're all loose, and I've done that. And now I look for solution. I'm going to put my restraint on, I put define nodes, I put apply, I put structural displacement on nodes, and I'm going to box the bottom of this cone. I'm going to be very careful I don't go too high. I box it in there, I box that in there, and I press apply. I put all degrees of freedom because it's completely fixed there. It's going to be free at the top. So that's fine. I'm now going to run it. I look on analysis type. I look on new analysis, and I put on modal because modal is to do with vibration and dynamics. I pick analysis options, and I pick on 6 modes to extract, 6, and 6 to expand. If you've got a big problem, you can do many more nodes than that, maybe as many as 20. I've done that. I press OK there, and I'm going to solve it. So I press solve current LS. I've done it. I press OK. It's got some numerical instability there, but as it's only a demonstration, it doesn't matter too much. It's done it. I close that, and I get rid of this. I do the general post processor. I pick on that, and I pick on read results. I pick on the first set. I pick on plot results. I pick on deform shape, and I get a shape. I get that there. That doesn't look too good, so let's put plot controls and animate it. The mode shape, Like that. I change the time delay to 0.075 and I press OK, and that's interesting there, but it could be more interesting if we look at it from the top. So I pick on plot controls and I pick pan, zoom, rotate, and I pick on top, do that. I'm going to put the plot controls again. I'm going to animate it, mode shape there, and there it is, vibrating like that. It's a ovaling mode. The frequency is 2,894 Hertz, which is quite high because it's a short squat model. So I now want to pick the next results. I put read results. Now because this is symmetrical, the next one will be exactly the same as this, but 90 degrees out, because it's symmetrical. So I don't want the next one, I want the one after the next. So I press next twice, I pick plot controls, I pick animate, I put mode shape, and I press OK, and there you are. I've got a vibration of cantilever mode, but the frequency is 4,694 Hertz. So that's fine. So let's have a look at the third one. Now remember this, because of the symmetry of this, I don't pick the next one, I pick the one after the next one, because the two are the same because of symmetry. So I pick next twice, with plot controls, pan, zoom, rotate, and I whoops, not pan, zoom, rotate, plot controls, animate, mode shape, there we are, I press that, and there you are. I've got n equals 3 lobes, so 3 lobes there, and that's fine. That's the end of my lecture. So thank you, ladies and gentlemen. A special thanks to my colleague Andrew Little for his input, and a very special thanks to Terry, who's made an enormous input into the use of ANSYS for structures. So I shall end my lecture now. Thank you, ladies and gentlemen.